Hello everyone. In this video, we'll learn how to compute normal probabilities using R. So we all know what the normal distribution is, and it's parameterized using mu and sigma. Now let's begin to solve some problems. So suppose we have a normal distribution. We have X normally distributed with mean 54 and variance of 8 square, which is standard deviation is 8. And we're asked to find the probability that X is less than 30. Now, remember that the normal distribution is a continuous distribution. So we won't be able to find out exact probabilities, but rather we'll be looking for areas in the curve, specific areas from lesser than 30, greater than some number, between two numbers, and so on. So we'll predominantly use the P prefix. We'll also have questions where, given a certain area below the curve, we are asked to find a particular point in the normal distribution such that the area above that point or the area below that point is given to us, which means we're doing the inverse. Given the probability, we're asked to compute the values. And for that, we'll use the Q prefix. So let's go over a few examples. So when X is normally distributed with mean mu 54 and sigma is 8, what's the probability that X is less than 30? So here the prefix is P, followed by the name of the distribution, which is nothing but norm, open brackets. Q here is nothing but 30. The second argument is going to be the mean. The third argument is going to be the standard deviation. Now let's go ahead and press Control Enter, and we get the answer as 0.00135. That's the probability that X is less than 30. What's the probability that X is greater than 56? Well, let's convert this to something which has a less than equal to sign so that we can comfortably use our cumulative distribution function. So this is nothing but 1 minus P of X lesser than or equal to 56. Remember that in continuous distributions, greater than is equivalent to greater than equal to, lesser than is equal to equivalent to lesser than equal to, because there are no exact probabilities. The probability at a specific value is 0. So whether you include the end limits or not, that is whether you use a strict inequality or a weak inequality, doesn't matter. So let's go ahead and find this. This is 1 minus P norm. 56 is our value of interest, 54 is the mean, and 8 is the standard deviation. Compute the answer. It is 0.40129. Now let's do the next one. So find the 80th percentile. That is, we want to find the value X such that the area of the curve below that particular point is equal to 80% of the data set, or 0.8. In other words, we want to find X such that probability that the random variable is lesser than or equal to this number is equal to 0.8 or 80% of the data set. So here we want to find X and we're given the probability. So we use the Q prefix. So we'll say Q norm. And the first argument here refers to the particular probability that lies below the point of interest. Okay, so we'll say that, lies below in the sense lies to the left of the point of interest. So we'll write 0.8. The mean of the distribution is 54. Sigma is 8. Let's do Control Enter. The answer is 60.73297. So if you want, you can always double check. You can check if the probability that X is lesser than or equal to this number, right? 60.73297 is indeed equal to 0.8. And how do we check that? I'll say P norm 60.73297 with a mean of 54 and sigma 8. Well, there we go. So this is exactly equal to 0.8. So our calculations are correct. Next one, find the 60th percentile. So I'm just going to copy this. So instead of 60th, 80th percentile, we want 60th percentile, meaning 60% of the area lies below this point of interest. So here we'll just do Q norm, 0.6, 54 and 8. The answer is 56.02678. And if I want to check if that is indeed happening, I can always do P norm of 56 point this number. Oops. Comma 54, comma 8. I should get an answer of 0.6. And there it is. It's pretty close. So that's how we solve these problems. The next, we have a different normal distribution. It is normally distributed with mean 6 and sigma 2. We want to find the area between 3 and 9. Now, if you recall how we solved this in class, we're going to compute the entire probability of the area below 9 and subtract from that the entire probability of the area below the value 3. And if you visualize this, you'll be able to clearly see that when you shade off the entire region below 9, and then you also shade off the region below 3, the difference between these two regions will actually be the area between the points 3 and 9, which is exactly what we want. And this is straightforward. So P norm 9, 54, sorry, it's not 54 here, the mean is 6 and the sigma is 2, minus P norm of 3, 6, and 2. And the answer is about 86%, and that is the answer to this question. So I'll let you do the next one, but I'll put down the answer here. This is going to be 0.1186, where you have a different normal distribution. Okay. So in the next video, we'll go over some calculations using the standard normal distribution, which will come in very handy when we do confidence intervals. So I'll put that in a different video. I'll see you there.